Hello, I am Maggie.
And I am Casey.
Well, we are obviously AI, but in this AI generation, agentic AI like us, shape the future in automation. And that includes enterprise-scale data and workload management. Today, we're going to demonstrate how AI agents can enable fully autonomous data mobility using Cirrus Data Cloud. But before we dive into the demo, let us first spend a quick minute or two giving you some important background context on how Cirrus Data approaches this transformation. Cirrus Data Cloud is a proven data mobility as a service platform for block storage and compute workload. Exabytes of data moved across production environments worldwide. This foundation is built on our patented TDI technology, Transparent Data Intercept, enabling non-disruptive migration with intelligent quality of service. We call it IQOS. Think of it this way: we don't bring out the construction crew on a concert night, even if it is after 10 p.m. While our intuitive user interface and developer-friendly APIs have always been highlights of the platform, a few years back, we created MigrateOps, our first-party data mobility as code automation platform built right into Cirrus Data Cloud. The concept of MigrateOps recipes encapsulates unlimited combinations of complex data mobility scenarios down to simple configurations with infinite horizontal scalability. For example, we can migrate from VMware to cloud platforms with precise storage control, modernize applications through migration, changing network configurations, even migrating backwards from cloud to on-premises when needed, and complex scenarios too, like migrating clustered applications from on-premises hypervisors to cloud platforms, with certain disks going to iSCSI storage like Elastic SAN, Pure Storage, NetApp Cloud Volumes ONTAP, or software-defined storage like Dell PowerFlex.
Hundreds or thousands of these operations can be orchestrated with a single intent-based configuration in one single click. And automation isn't just another feature in Cirrus Data. It's in our DNA.
So our goal doesn't just stop there. Our automation-first approach over the years, from one-click migration, single-command repeatable deployment, to IQOS, auto-configuration discovery, and I/O performance analysis, it all points towards one ultimate direction: fully autonomous operations, from planning to design to execution. Zero-click migration. So how do we make it possible? Partnering with agentic AI. Cirrus Data Cloud's MCP server will allow any of your favorite AI agent, any agentic AI, to do that. As an information provider to plan your migrations, and as an execution platform to fully autonomously execute all the data mobility scenarios that we now support. And that includes all the upcoming capabilities like files and objects. It is not just about the MCP server. Anybody could simply create one. Our secret sauce is our years of automation-first philosophy that always aims to make it easier and safer for engineers to integrate with Cirrus Data Cloud. And now, that applies to AI engineers as well.
All right, time for our demo. In recent years, we have been showing our partners and friends how to efficiently migrate storage or even compute workload to any preferred environment. We are walking through videos on all kinds of storage and workload migration scenarios, which showcases how Cirrus Data's data mobility as a service solution automates the entire migration process from start to finish. All of these capabilities still apply, except in this demo, an AI agent will be doing what human users normally do manually. For demo purposes, instead of direct instructions, we are going to break down our flow to create different prompts to interact with our AI agent in chatbot style. However, if it isn't for this demo, we can simply set up our AI workflow and have this run by itself. We are using Anthropic's Claude Code as the AI engineer for our demo today, but this works with any kind of agentic AI, open source ones, commercial ones, or the one you're building right now. It will be mostly me talking since there is not much of clicking. Our AI engineer will be doing all the work. Let's see it in action. All right, similar to what we have demonstrated before, we'll be migrating VMware virtual machines to Microsoft Azure. This is the same exact environment that we have used in our previous demo, which is our Windows 2016 machine, running on a VMware server as our migration source, with a 20 gig boot drive and two 1 gig data drives. Our TDI technology eliminates our dependencies on vendor-provided technology like VMware snapshots, allowing us to migrate any block storage, including virtual machines with RDM devices. It's also worth noting that this same process throughout the demo, including the MCP server, works identically with Cirrus Data Cloud Private Edition for organizations requiring the Cirrus Data Cloud control plane to be private. For our destination, we are migrating to the same Microsoft Azure environment that we have shown in our previous demo before. I am keeping it simple by using our E2E resource group with the existing demo network. On the side, we will use Notion today for tracking our application issue and migration guidelines. But of course, Notion is just an example of my choice because that's what our engineers use on a daily basis. And this can also be any project management tool you normally use like Linear, Jira, or even just a spreadsheet in Google Drive. Before we dive in, let's talk about Cirrus Data Cloud's integrations. We support incredible flexibility. There's Azure Managed Disks, which we'll use today, and there is also Azure Elastic Sand. You should definitely check out our other step-by-step video demo on setting up the integration that suits your specific need or use case in details. You can mix and match destinations, but today we're keeping it simple with just using Azure Managed Disks. But with anything that we support, thanks to the concept of MigrateOps recipes, there is no special training, programming, or prompting required. With the MCP tools that Cirrus Data Cloud provides, AI agents know precisely what to do by itself. Now let's dive in. This is my Claude Code environment, and let's take a look at the MCP servers that we enabled. The very first thing we have, of course, is our Cirrus Data Cloud platform. One of its two critical roles is to be the information provider that helps us plan the migration. It will give the agent disks usage information, reports, device access patterns and performance, system and storage configuration. And the next thing, of course, is the role as an execution platform to actually execute the migration just like what human users normally do. Then we have the Microsoft Azure MCP server for the Azure account info like resource groups, subscriptions, and network configurations. We also have Microsoft Docs that will provide us up-to-date Azure documentations, which allows our AI agent to perfectly plan our migration through research on best practices. And we have Notion that I just showed you as an application issue tracker, and it will hold our internal documentations that AI agent can reference throughout our operation. We also have GitLab to access data, such as projects, issues, and merge requests. This way, our agent could open a ticket to get our human engineers' attention to work together if anything happens. And what's great about the following demo is that we don't even need to connect to VMware. Cirrus Data Cloud already provides our AI agent everything needed, from configurations to device usage and performance statistics. And now, let's see it in action. We will start by asking our agent to access our Cirrus Data Cloud projects as it needs to understand what we're working with. Our agent has accessed Cirrus Data Cloud to list all the projects from our account, and we have 8 projects. It is also telling us that most of them have already had hosts registered, including VMware, OpenStack, and physical servers, both Linux and Windows. We'll tell our agent that we are using the migration demo project today. While doing so, let's also checking the access to our project management tool, which is our Notion page, to ensure that the connected resources are visible to our agent in Claude Code. And our agent is using the Notion MCP server. Great! We can clearly see that our agent is connected to Notion, and it has found the application issue tracker database and our VM migration tracker database, which is what I have here, and this will be useful in the next part of the demo. Moving on, we'll tell the agent our intention to migrate all 2016 Windows Server and perform a thorough analysis on the storage devices we have. We'll also utilize the Cirrus data provided disk usage and performance statistics to make the decision on what managed disk to use. We can see that it is analyzing and created a to-do list with the first step to identify the applicable servers, and our agent has been using Cirrus Data Cloud provided information to do its job. Perfect. Even before our agent has completed all its tasks, we have already identified our Windows 2016 server, where it does it based on the discovered information in Cirrus Data Cloud.
Quick note, if you want to know more about how we install and register hosts on Cirrus Data Cloud, we simply deploy CMC by copying and pasting the installation command on your shell, and it will be done all by itself. This same installation command can be used on as many hosts as you want. The migration process of Linux hosts is more or less identical, and all you need is to install with a different installation command.
You can run the command manually like what Maggie just referenced, or install through the automation of your choice, or even just let your AI agent run the installation autonomously at scale. Back to where we left off, you can see that our agent has already retrieved the storage configurations that Cirrus Data Cloud discovered quickly. It has collected our disk performance statistics, analyzing device access patterns and workload characteristics, all using Cirrus data provided information. Look at this. We can see our 20 gigabyte boot disk, 1 gigabyte data disk, and they are the same as what we have here from VMware. However, all of this comes from Cirrus Data Cloud's data collection. We didn't even need our AI agent to access VMware, and Cirrus Data Cloud has already provided the AI agents everything needed. Just like what we've shown you in other video demonstrations before when we analyze them manually, Cirrus Data Cloud knows everything about your configurations. And now your AI agents can also use this to plan and execute your migration. Our agent pointed out that our S3 test bucket drive has extremely high I/O per second, and it will take that into consideration when it comes to migration. So next, the AI agent consulted the Microsoft documentation on the types of storage that's available in Azure to make sure it fits our workload. It then utilizes all the key findings and gives us a recommendation, even with the estimated monthly cost of what it recommends. Once again, we are displaying our step-by-step conversation for the purpose of this video demo. In actual production, instead of chatting with our agent, you will likely pre-configure your agent with instructions in, say, your agent's MD, or in this case, our Claude MD file, because we are using Claude code. And if you're building your own agents, these workflow can be built right into it. AI will do everything completely autonomously in one go. All right then, from the Cirrus Data Cloud provided information and the up-to-date Azure storage product information gathered from the Microsoft Docs tool, including pricing, our agent has already come up with a completed recommendation. If we come down to look at the S3 test bucket, we can see the current state and the purpose. Through this, our agent has recommended the premium SSDP15, and it is sufficient for our test workloads. Before we create the MigrateOps configuration, let me do a final round of checks. First, I will verify our Azure integration is properly set up and enabled. The agent automatically goes and checks if we have an Azure integration configured. Perfect. We found the Azure E2E test integration. There's nothing new about this. The process is the same as how we normally set up our integrations here on Cirrus Data Cloud. And since our agent has found and verified it, we're good to proceed. Oh, and there is one more thing. Let me remind the agent to make sure we have enough migration licenses. It has requested license information. Everything checks out, and we're good to go. Next, let's draft out the migration plan. Again, this is to demonstrate the flexibility, but these steps are completely optional. Whether you want to draft a YAML and manually review first or do it differently, it varies from how your organization implement agentic AI in your workflow. Our agent is now creating a migration plan document. It will include the pre-migration checks, define Azure target configurations, document MigrateOps configuration, and add post-migration validation steps. This is just so we can have a good plan for review before actually creating the migration configuration. After a brief moment, our migration plan is created. And remember, this is completely based off Cirrus data provided information. And now it is the moment we've been waiting for. I'm telling our agent to create a MigrateOps configuration from scratch with the correct format for our Windows host. Our AI agent instantly has access to all different kinds of recipes and knows exactly what to do. This is thanks to Cirrus Data Cloud's purpose-built MigrateOps recipes. This process is the same as how we manually build a configuration through the references from Cirrus Data Cloud. It's just that this time, I don't have to do it myself. And now, it is writing the configuration file. Now, our MigrateOps configuration YAML file is created. This works exactly like how I would build the configuration manually, where all of the specifications would match our intent. And of course, we can always come back to our agent and interfere as much as we want to customize our migration configuration like I normally would. But let's take a moment to go through what else we can do from the MigrateOps configuration reference on Cirrus Data Cloud. There are lots of customizable settings, one including the ability to configure custom actions. You can automatically install packages, uninstall legacy software, and modernize your applications as part of the automated workflow. Since there is so much that we can do, let's even take a step further to stop the antivirus service and clear all my event log after migration. And there it is. Our agent has applied to post-migration action for the antivirus and added a customized script to clear event log as part of our configuration. Exactly from what I just showed you regarding our MigrateOps reference to perform post-migration automation. Our agent has learned the actions from our platform completely and applies them like how a human would do. Let me show you one more quick example. Let's tell our agent to unmount the F drive since we won't need that at our destination. And there it is. But this time, instead of writing custom script, it uses the pre-built actions that Cirrus Data Cloud provided. I don't think we need any more explanation here. Our operation is ready. So that's it for the planning phase. We can now submit our prepared YAML to Cirrus Data Cloud. Let's drag and drop. Nope, we are not doing it by hand with the user interface this time. You can still do that as they work in the same manner, but we'll just tell our agents to create the operation in Cirrus Data Cloud. We will also cross-check with our issue tracking Notion page that there is no outstanding issue for this host. And yeah, our agent automatically knows where to check. It is checking for any unresolved block issues from our tracker. There seems to be an issue blocking us. Let me just check this off so we can proceed. And tell our agent to check again. Perfect. There's no blocking issues now. Our migration operation could start at any minute now, so let me pull up our MigrateOps interface to see what's going to happen. Uh-oh, there's a syntax error. Wait, never mind. Our agent has self-corrected its mistake on the storage type, and boom, the migration operation has started. We can also keep tracking our current state without looking at our Cirrus Data Cloud interface at all, since our agent could monitor this, provide updates, handle issues, generating report, sending emails, whatever we need. Well, since there's nothing much that I have to do from now on, as the migration is fully automated, I'll tell the agent to log the migration in the VM migration tracker in Notion. And yes, from our VM migration tracker, we can see this new entry has automatically been added. Just a reminder regarding Notion, this is our internal decision to track it this way, but you could have used any other project management tool and instruct your agent to do it your way. From the Azure environment, we can see that an Azure VM is already up and running, and migration is progressing happily. Well, this point onwards, you know the drill. MigrateOps will now take over and get the job done, just like how when it is done manually. If you have seen our previous migration demo, you know how this will go. Once the operation has continued with cutover and completed all tasks, our operation is completed, and our migration report has been generated. We can also validate it from our destination Azure environment, where our new Windows virtual machine should be up and running. Connecting to the host, we'll be able to see that our machine is running and data is mounted. This entire server has been migrated to Azure successfully.
By the way, we only used Azure Managed Disks today, but if you're interested, please check out our other video demonstrations where we successfully migrated our boot drive to Azure Managed Disks, and all data volumes are migrated to Azure Elastic SAN. And we no longer need to manually program or prompt anything after the single step of submitting the job.
So that is how an AI agent can easily plan and orchestrated migrations using Cirrus Data Cloud. Let's recap what just happened. The AI agent accessed Cirrus Data Cloud to discover our environment, pulling host information, storage configurations, and device performance statistics. It simultaneously consulted Microsoft's documentation to understand Azure Managed Disk specifications, then made intelligent recommendations based on real production data that Cirrus Data Cloud provided. From there, our agent generated a complete MigrateOps configuration through storage type selections and network mappings, and even enabled post-migration automation scripts. We validated against our company policies in Notion, checked Azure integration status, verified license availability. Everything we demonstrated today are done autonomously. And we eventually submitted the operation to Cirrus Data Cloud with our AI agent.
But like we said earlier, there is no magic about an MCP server. It is the power of MigrateOps, which we talked about today, that made all of these happen. Since day one, Cirrus Data Cloud and MigrateOps was designed for agentic AI to be the ultimate users. With this vision, we provide information and also autonomously carry out the tasks. We made it as easy as possible for human engineers, as safe as possible for our enterprise to develop automations. And now, in this AI generation, AI agents automatically benefit from all these. And remember, this is designed for any agentic AI platform. Whether you're using a coding agent like we just did, or you are building an AI agent as a product or for your organization, it works the same way. Thanks for watching.
And welcome to the future of data mobility.